A+ on this test to get your deriver's license, but you do need to get an A+ on the section where you list the derivatives properly. Okay, so the calculus of the exponential function. The derivative of e to the x is e to the x. The most wonderful derivative of all. Some people say that e to the x is confusing. No. Back when we were doing college algebra last year, when we were talking about exponential functions, people would say, well, you know, e to the x, why not just have like 2 to the x or 3 to the x? Everyone wants a number. What makes e to the x super special is, again, the derivative of it is itself. Whereas if you had the derivative of something else, b to the x, meaning the base was, say, 2 or 5 or 10 or something like that, then the derivative is not simply itself. It is b to the x times the natural log of the base. So that's the difference. For your deriver's license, you only need to memorize that one. The second one doesn't come up very often. But if you're anything like me, I would be saying, what if the base isn't e? And I would want to know. Well, now you know. So let us go about finding some derivatives and then giving you some work time. What do you think about this first one? What comes to mind? X to the third times e to the x. Product rule, good. So f prime of x is equal to the derivative of x cubed
3x squared
times e to the x plus x cubed times, what is the derivative of e to the x? Oh, look at that. I'd accept that. However, I will say that most commonly this would be written in factored form because you can take out an e to the x. And if I take out an x squared and an e to the x, you can see that I'm left with 3 plus x. Not too bad, huh?
He's kicked upside down.
The next one is where we kind of get into the heart of the derivative of e to the x, and we are going to set this up as e to the u. So what would u be? Four x squared. The derivative of 4x squared? 8x. And the derivative of e to the u? E to the u. And so f prime of x becomes 8x times e to the 4x squared. Do you remember that day where I showed you that the derivative of sine was cosine? We took about 25, 30 minutes. We had that long proof. We would do a similar thing to find out that the derivative of e to the x is e to the x. Okay? And so we're not going to do that. Okay? I kind of did that one day to show you how we go about that stuff, but we're not going to do that again. How about this one? Letter C. Let's do the quotient rule.
I was about to do multi-ideas. Hey, I love good slap.
Derivative of the top is e to the x times 2 minus x minus the derivative of the bottom. So it will be then plus times the top over the bottom squared. So I get f prime of x is equal to, can I cancel off a 2 minus x?
Why not?
Definitely not. Right?
Oh, okay. It's because it's small. Right.
Could I factor in e to the x on the top?
Yes.
E to the x times a 2 minus x plus 1 over 2 minus x, quantity squared. Notice we could combine like terms, e to the x times 3 minus x over 2 minus x, quantity 90 squared. So really, we are just focusing on applying derivative rules again, aren't we? Okay, just with different derivatives. What do you think? Any thoughts how I set this one up? Chain rule. What's the inside? What's the outside? 4 to the U. Good. Man, you guys are smart.
Some days.
Derivative tangent for your driver's license is? Secant squared. Good. What are their names again? They're coming again. Abby and Maya. Hi, Abby and Maya.
Hi.
How are we doing?
Good.
When's the birthday?
August,
August. We missed it, huh?
I guess.
That's unfortunate.
Need some oil.
This is what happens when you get old. This is what happens when your face is put in front of a screen every day.
Right.
I should demand workers' comp.
Why not? Why not?
Okay, the derivative of 4 to the u is like the derivative of e to the u. The only difference is instead of just 4 to the u, you also have to attach the natural log of 4 to it.
What? It's okay.
So a lot of people do get upset by that. We did get the reaction from at least 2 of you at this time. I just want to note, if it's e to the u, the derivative is e to the u times the natural log of e. The only difference is the natural log of e is 1. So that's why it disappears. So it always is times the natural log of the base. Okay, we'll put so then we gotta multiply it. So we got 4 to the tangent of x times the natural log of 4 times secant squared. Kind of an ugly derivative, but
Hey, there's beauty in everything.
there's beauty in everything. This is pretty cool.
Looks awesome.
What are you gonna set up? Okay,
Probably twice.
we got e to the u, and then the inside is 3 sine cubed of the root of x.
We're gonna need another chain rule, I think.
You think right.
I don't like it.
So what would be the next setup for my chain rule?
This one's strictly.
Good, excellent, 3u cubed.
Right.
And what is it that we are cubing? Sine of the root of x.
Right. Obviously.
What's the derivative of 3u cubed? 9u squared. How do we find the derivative of sine of the root of x?
I think I'm gonna need it.
I think we need another chain rule.
I think I'm
This is a long chain.
I think I'm starting to like the chain.
So I've got sine of u, and I've got the root of x. So here's how I try to navigate these. I set up my chain rules just like that. The derivative of sine is cosine. You guys are well on way to getting your driver's license. The derivative of the square root of x? 1 over 2 roots of x. So now I multiply these together, and that's what goes in this box. And on the top, I get the cosine of the root of x. On the bottom, I have 2 roots of x.
Okay, now I'm just gonna do this one more time.
Yep. Now I multiply those 2 together, and that goes in the next box. And I get 9 times sine squared of the root of x times cosine of the root of x.
Okay.
All over 2 roots of x.
Okay, now I'm just gonna do this one
And finally, I multiply these two expressions together. And so I get f prime of x is equal to 9 e to the 3 sine cubed root of x times sine squared of the root of x times cosine of the root of x, all over 2 roots of x.
Right. I need to start that problem. I just
Chain rule 3 times. The boxes are helpful when you're organizing your work, isn't it?
Now let's take the derivative of that. Stop.
Oh!
Stop it.
Wow, yeah. Challenge accepted.
See, we have a little extra room on that paper.
How about this? We'll heed to Rosa's suggestion and say that anybody who takes that derivative and comes up with the correct answer tomorrow, I'll bring you a donut.
Here tomorrow. Have it by Monday, okay?
All right, just 2 left. These are a lot easier. I'd like you to try. We'll go through E together. We'll just go through. I don't have to do that. What do I set up? Chain rule, good.
Right. Okay.
Tell me more. U to the 1/2. 4 minus e to the 4x. Derivative of u to the 1/2. And then the derivative of 4 is 0, right?
Right.
So the answer is going to be negative because of the subtraction sign. But now I need the derivative of e to the 4x.
Okay.
And this is where people make their mistake on their test. So I'm trying to be very transparent with you about what people do well and what they don't. Sometimes people don't see that you need the chain rule. Again, we know the derivative of e to the x is e to the x. But if it's e to something else, then we need the chain rule.
Right.
Now, it just works out every single time that when you have e to something, the derivative of e to the u is e to the u, and the derivative of 4x is, sorry for that, I'm thinking ahead. E to the u is e to the u, the derivative of 4x is 4. So we multiply these together, you get 4e to the 4x. So the cool thing about the derivative of e to something is you just take the derivative of the exponent and drop it in front. So for example, suppose you had e to the 8x squared. I know the derivative is 16x e to the 8x squared. You know what I'm saying? You just take the derivative and drop it in front. That's how it happens every time for e to something because the derivative e is itself. So that's something that can kind of help people navigate as they try to move quickly through problems. So now I multiply these together. Do you see something that will reduce? The 4 and the 2, so I'll just get a negative 2e to the 4x in the numerator. And then in the denominator, I have the root of 4 minus e to the 4x.
Boom.
And our last example of the day is letter F, secant of e to the a pi x. A and pi are treated as constants. Neat question here because there are no numbers, really. I guess e is a number, right? But it looks like a letter. Let's take the derivative. We set up the chain rule. Secant of u and e to the a pi x.
Right.
The derivative of secant is? Secant tangent. Very good. Mika knows her derivatives.
I have to freshen up on that. Yeah.
Only got one person here getting her driver's license. Is that what you're telling me?
No, I just gotta freshen up.
All right, okay. E to the a pi x. Remember what we just talked about. When it's e to something, you could just take the derivative of the exponent. And there's a constant in front here. So if it was 9x, the derivative will be 9. So if it's a pi x, then the derivative will be a pi. So we have a pi times e to the a pi x.
Oh my gosh.
And so f prime of x is equal to a pi e to the a pi x times the secant of e to the a pi x times the tangent of e to the a pi x. Doesn't that look kind of cool?
What did you say? When can you use the thing where you take the a pi e? How do you end up with that?
Yeah, so if we were to look at this as, say, e to the 9x, we know the derivative is 9e to the 9x, because the derivative of 9x is just 9.
Okay.
So since it's a pi is just the constant, that comes in front.
Okay.
Better?
Mm-hmm.
Good question. That's my derivative. Your assignment. Yeah.
Right.
How are you keeping up with your homework? Are you doing well?
Yeah, I have some questions. But...
So, Mika crossed off number 4 altogether, which is the right thing to do. Okay? No, and then she did the other 3, right?
Yeah.
And I think I have all those posted online. And now she's ready for the derivative of the exponential function. So I got front and back. You've got 25 minutes to work. You should be able to get at least half of it done, I'm guessing. Okay. And then tomorrow is the derivative of logarithmic functions. And then Monday is our inverse trig functions. And that'll be that.
No question.
I'll get you a study guide on Monday. We test on Thursday.
Are these the same as this?
Yes. Yep. Yep. So just like you did.
Don't ask me questions about those. I'm not going to.
Yes. And then y double prime.
Okay.
So this problem follows basically identical to this one. The only difference is that this one has a 4, this one has a 9.
Okay.
But you're going to follow the same process. That should simplify quite nicely. Hi.
Hi. So I don't quite understand this.
Oh yeah, that's a good one.
Wait. Yes, that's the one I had a question on.
You want to do that one too?
Yep. Me too.
Okay, then I'll put it up on the board.
It's the one we couldn't figure out in criminology.
Yes. Okay.
Yeah.
Oh, whoops. Let me see if did I stop my video? Stop my video.